Welcome to this comprehensive guide on optimizing your game's performance by analyzing GC allocations and frame performance in Visual Studio and Unity 3D. This tutorial is designed to provide a clear, step-by-step approach for beginners looking to enhance their game development skills and create more efficient applications. We will delve into the core concepts of memory management and rendering efficiency, crucial for any aspiring game developer. Understanding how your game utilizes memory and processes frames is crucial for creating smooth, responsive experiences, especially for beginners. A well-optimized game not only runs better on a wider range of hardware, but also provides a more enjoyable and immersive experience for players. This foundational knowledge is key to building high-quality games. Garbage collection, or GC, is an automatic memory management process that reclaims memory no longer in use, preventing memory leaks. In essence, it's like a cleanup crew for your game's memory, automatically identifying and freeing up resources that are no longer needed. This process is vital for maintaining application stability and preventing crashes due to excessive memory consumption. However, frequent or large GC allocations can introduce performance spikes, causing noticeable hitches or stutters in your game. These momentary pauses can severely disrupt the player's experience, making the game feel unresponsive or unpolished. Identifying and mitigating these spikes is a primary goal of performance optimization. Frame performance, on the other hand, refers to how consistently your game renders frames per second, directly impacting visual fluidity. A high and stable frame rate ensures that animations appear smooth, input feels responsive, and the overall visual presentation is seamless. Fluctuations in frame rate can lead to a choppy and unpleasant gaming experience. Our journey begins in Unity 3D, where we'll use the built-in profiler to identify performance bottlenecks. The Unity Profiler is an incredibly powerful tool that provides real-time insights into various aspects of your game's performance, from CPU and GPU usage to memory allocation and rendering statistics. It's your first line of defense against performance issues. Open the Profiler window by going to Window, Analysis, Profiler. This powerful tool provides real-time data on your game's performance. Once opened, you'll see a wealth of information presented in various graphs and modules, each offering a unique perspective on how your game is utilizing system resources. Familiarizing yourself with its interface is the first step. To analyze GC allocations, focus on the CPU usage module within the profiler. Look for spikes in the GC alloc row. This specific row tracks the amount of memory allocated by the garbage collector during each frame. Significant spikes here are often indicators of inefficient memory management practices within your code. These spikes indicate moments when your game is allocating significant amounts of memory, potentially causing performance hitches. Each time the garbage collector runs to clean up this allocated memory, it can introduce a brief pause, leading to those undesirable stutters. Understanding the timing and magnitude of these spikes is crucial for effective optimization. A common cause of GC allocations is creating new objects or strings frequently, especially within update loops. For instance, instantiating new game objects, creating new lists, or concatenating strings repeatedly inside a update method can quickly lead to a buildup of temporary memory that the GC then needs to clean up, causing performance overhead. To get more detailed information, select a frame with a GC spike in the profiler timeline. By clicking on a specific frame that exhibits a spike, you can drill down into the events that occurred during that particular frame. This allows for a more granular analysis of what exactly contributed to the memory allocation. Then, expand the GC alloc section in the detailed view to see which functions are responsible for the allocations. This detailed breakdown will show you the call stack, pointing directly to the methods and lines of code that are generating the most garbage. This information is invaluable for pinpointing the exact source of your GC issues. Tip: object pooling is an excellent technique to reduce GC allocations by reusing objects instead of constantly creating and destroying them. Instead of instantiating and destroying objects like bullets or enemies, you can maintain a pool of pre-instantiated objects and simply activate or deactivate them as needed. This significantly reduces the workload on the garbage collector. Now, let's shift our focus to frame performance.
In the Unity Profiler, monitor the CPU usage and GPU usage modules. These two modules provide a comprehensive overview of how your central processing unit and graphics processing unit are performing, respectively. Understanding their interplay is key to diagnosing frame rate issues.
High CPU usage often points to heavy scripting, physics calculations, or too many active game objects. If your game involves complex AI, intricate physics interactions, or a large number of active entities, the CPU can become a bottleneck, struggling to process all the necessary logic within a single frame. Optimizing these areas can significantly improve CPU performance. High GPU usage typically indicates complex shaders, too many draw calls, or high-resolution textures. The GPU is responsible for rendering all the visual elements of your game. If it's overloaded with detailed graphics, numerous lighting effects, or an excessive number of objects to draw, it can struggle to keep up, leading to a lower frame rate. Efficient rendering techniques are crucial here. The frame time graph at the top of the profiler provides an overall view of how long each frame takes to render. This graph is your primary indicator of overall game performance. It shows the time elapsed between the start and end of each frame, giving you a direct measure of your game's frame rate. A lower frame time means a higher frame rate. If your frame time consistently exceeds your target, you have a performance bottleneck. For a smooth 60 frames per second, each frame must be rendered within approximately 16.67 milliseconds. If the frame time frequently goes above this threshold, it means your game is not meeting its target frame rate, and players will experience choppiness. Tip: batching draw calls, optimizing shaders, and reducing overdraw are effective ways to improve GPU performance. Batching combines multiple small objects into fewer, larger draw calls, reducing GPU overhead. Optimizing shaders ensures they run efficiently, and reducing overdraw minimizes the number of times pixels are rendered unnecessarily, all contributing to a smoother visual experience. Now, let's transition to Visual Studio for deeper code analysis, particularly for C# scripts. While Unity's Profiler is excellent for high-level performance overview, Visual Studio offers more granular insights into your C# code, allowing you to pinpoint performance issues directly within your scripts. This integration provides a powerful debugging and optimization workflow.
Visual Studio's diagnostic tools can help pinpoint specific lines of code causing GC allocations or performance issues. These tools are designed to profile your application's execution, providing detailed reports on CPU usage, memory consumption, and other critical performance metrics. They are an indispensable resource for any serious game developer.
To begin, run your Unity game from Visual Studio by attaching the debugger to the Unity Editor process. This allows Visual Studio to monitor your game's execution in real time, collecting performance data as you play. It's a seamless way to bridge the gap between your game engine and your code editor for comprehensive analysis.
Once attached, open the Diagnostic Tools window by going to Debug, Windows, Show Diagnostic Tools. This window will become your central hub for performance analysis within Visual Studio. It consolidates various profiling features into one accessible interface, making it easier to track down performance bottlenecks.
Start a diagnostic session by clicking the Record button in the Diagnostic Tools window. This initiates the profiling process, and Visual Studio will begin collecting data on your application's performance. It's important to start recording before you trigger the performance issue you're investigating to capture a complete dataset. While your game runs, interact with it to trigger the performance issues you're investigating. This active engagement ensures that the diagnostic tools capture relevant data related to the specific scenarios where your game experiences slowdowns or hitches. Reproducing the issue during profiling is key to understanding its root cause. After capturing enough data, stop the recording. The diagnostic tools will then present a summary of the session. This summary provides an overview of the collected performance data, including CPU usage, memory allocations, and other events. It's your starting point for diving deeper into the analysis. For GC allocations, navigate to the Memory Usage tab. Here, you can see the total memory allocated and identify specific object types. This tab offers a detailed breakdown of your game's memory footprint, showing you which types of objects are consuming the most memory and how that consumption changes over time. This is crucial for identifying memory leaks and excessive allocations. Take a snapshot of the heap at different points to compare memory usage and pinpoint where allocations are occurring. By taking snapshots before and after a specific action in your game, you can compare the memory differences and identify exactly what new objects were allocated. This technique is incredibly effective for tracking down the source of persistent memory growth. For frame performance, the CPU usage tab is invaluable. It shows you which functions are consuming the most CPU time. This tab provides a detailed call tree, illustrating the execution path of your code and highlighting the functions that are taking the longest to complete. This allows you to identify performance hotspots directly within your C# scripts. You can drill down into the call stack to see the exact path of execution that leads to performance hotspots. By expanding the call tree, you can trace the sequence of function calls that contribute to a particular performance bottleneck. This level of detail is essential for understanding why certain parts of your code are running slowly and how to optimize them. Tip: use struct instead of class for small. Frequently use data types to reduce heap allocations and GC overhead. Structs are value types and are typically allocated on the stack, which is much faster and doesn't involve the garbage collector. This can lead to significant performance improvements in scenarios where many small objects are created and destroyed.
Another tip: cache references to components or objects instead of calling getComponent or findObjective-type repeatedly. These methods can be computationally expensive, especially when called frequently within update loops. By storing a reference to the component or object once, typically in awake or start, you avoid redundant lookups and improve performance.
Remember to always profile your game on the target platform, as performance characteristics can vary significantly. What runs smoothly on your powerful development machine might struggle on a less powerful target device. Testing on actual hardware ensures that your optimizations are effective for your intended audience and provides a realistic performance assessment.
By consistently applying these analysis techniques, you'll gain a deeper understanding of your game's performance profile. This continuous process of profiling, identifying bottlenecks, and optimizing your code will become a fundamental part of your game development workflow. It's an iterative process that leads to increasingly polished and efficient games.
This knowledge empowers you to make informed optimization decisions, leading to smoother, more enjoyable player experiences. A game that runs flawlessly and responsively is a testament to good development practices and a commitment to quality. Your players will appreciate the effort you put into delivering a high-performance product. Thank you for joining this guide. Keep practicing these techniques to master game performance optimization. The journey to becoming a proficient game developer involves continuous learning and refinement. We encourage you to experiment with these tools and apply them to your own projects to see the tangible benefits of effective performance analysis.